calculators, that's abbreviated by removing the base 10 and just writing it as log x. In a similar way, we talked about a special exponent function. There is a special logarithm function called the natural log, and it's abbreviated ln of x. This is the same thing as log base e. This logarithm shows up very often. It's a very useful logarithm, and most people favor this over this one just because it's a little easier to work with. So typically when I solve most problems involving exponents and things like that, I'll use this logarithm. And in calculus, this is one of the more useful logarithms. Shows up a lot, and we'll see sort of what its uses are as we move through the class. But most often, I will use this logarithm.
To go with like PERT and all that?
When solving when solving exponential growth or exponential decay equations, this logarithm shows up most often. We'll see another use for it here in just a minute. But before we go too far, let's talk about some of the simple properties of logarithms that we can exploit. So, the algebra of logarithms. All right, so the first one. And actually, let me take one moment here before I go too far. These logarithm functions, these logarithm things, they're functions. You can think of them as f of x type things. Okay? This ln of x, this is a function. These letters don't mean anything else except for this is a special function. If you see ln of x divided by ln of y, these letters mean something. They're not something that you can just say, oh, well, just go over the dot. There we go, x over y. We can't do that. These things are functions. We cannot just cancel them out of the top and out of the bottom as we see fit. They have specific meaning, and we have to leave that meaning in there. We cannot cancel logarithms just because one shows up at the top and one shows up at the bottom. We can't do that. So don't ever, 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 ever cancel logarithms in this way, because it's not allowed. It's not something you do. Okay? Just like if you see f of x divided by g of x, you don't cancel the x's out and be left with f over g. F of x and g of x are specific functions, and we need to keep them as that. We can't just cancel the letters because they're the same at the top and at the bottom. Okay? All right, that being said, let me get back to our properties here. So, first thing, b is going to be greater than 0, and x is also going to be greater than 0, just to make things work nice. And the first one says, suppose we have the log of b times x. Whenever we take products, whenever we're multiplying things inside of logarithms, logarithms work in a nice way that allows us to rewrite this as a different rule. So if I take log base a of b times x, that's the same thing as taking log a of b and adding log a of x. You might ask why? Well, if you go back and look at this in terms of exponents, right? A to the y equals bx. Okay. Again, if you redo this, this is a to the y plus, oops, sorry. I don't want to do that. Rewriting on the right-hand side, again, this stuff, this is just redoing this in terms of exponents. Okay. How many exponents do I need to get b times x? Well, it's the same number of exponents as I need to get this, plus the number of exponents to get to that.